to matrix lecture series. In the last lecture, we saw how we do the matrix multiplication. Today, we are going to discuss the properties of matrix multiplication. So let us begin with today's discussion. Yes. So here is the topic of our discussion, the properties of matrix multiplication. Now, if you have seen my video in which I have discussed the properties of addition of matrices, then you can very much correlate in this video. See, I have already discussed the property of matrix commutativity. I have already discussed the commutativity property in case of matrix multiplication. You might have remember I have discussed it in the last class, and I told you that in matrices the property of commutativity may hold or it may not. I have also told you the various scenarios in which the property of commutativity holds and in which it does not holds. If you do not know about this, you can refer to the last video. Now we will today discuss the property of associativity. Now, as the name suggests, associativity, we will associate. What we will associate? We will associate the matrix multiplication. If you see here, the B matrix is first multiplied with A matrix, then it is multiplied with C matrix, right? Here in the right hand side, we can see that B matrix is first multiplied with C, then it is multiplied with A. So this is how the B matrix is associated differently. First it is associated with A, then it get multiplied with B, and in the later part it is associated with C and then multiplied with A. This is how we define the associativity. And why we are considering the multiplication? Because we are discussing the property of multiplication of matrices. In case of addition, if you can remember, we discussed the matrices, we discussed the associativity property like this: B plus C is equals to A plus B plus C. As you can see here, the B matrix is first associated with C. How it is associated? It is associated via addition, and later it is associated with A. Again, how it is associated? Again by addition. Why? Because we were discussing there the properties of matrix addition. Now we are discussing the property of matrix multiplication. So the multiplication is the operation, right? Now I have told you the example in addition. In the similar manner, you can see that the property of associativity holds in case of matrix multiplication. Just simply we can take the example. Let's take A, B as these matrices, and our C matrix, let's say it is 1 0 0 1. Okay, let's consider this matrix. Now AB matrix is this, right? If I multiplied AB with C matrix, okay, what will I get? If you multiply, you will get 0 0 0 0. You can cross check by yourself. By the way I explained you how we multiply, you can cross check. When I multiplied AB with C, we get this. Now if I multiplied BC and then multiplied with C, let's see what happens. Now first I am multiplying B and C. Okay, so this is B matrix and this is C matrix, right? If you multiply, how we will multiply? We will multiply this row with this column, then this row, this column, then we will move to this row and this column, this row and this column, right? As I have explained you in the last video, we will multiply in this manner. After multiplication, what I get? I get 3 5 0 0. You can cross check by yourself. Okay, so this is my BC. Now if I multiply my BC, let me erase this part. Yes, if I multiply this BC with A, then let's see what happens. This is my A, okay, and this is my BC. It is 3 5 0 0. Let's see what happens. Due to the unavailability of space, I am writing very congested. You can manage it. So after multiplying, what I am doing? I am actually multiplying BC with A. What happens? let's see again the same way of multiplication is applied here. This row and this column, then this row, this column, this row, this column, and this row, this column. I hope it is clear to you. Okay, so if I multiply it, what I will get? This becomes 0, so this is 0, it becomes 0, 0 and 0. This is my A times BC, and if you remember, my AB times C was also the same matrix 0 0 0 0. So here I can say that both of these way of multiplying are giving me the same answer, giving me the same matrices. Therefore I can say that yes, the property of associativity holds in case of multiplication of matrices. Hope it is clear to you. Now the distributive property, basically as the name again suggesting to you that it is distributive, the things are getting distributed. Here the A matrix is distributed over this. This is actually said to be the matrix distribution over addition. This A matrix will multiplied with this B and I get AB, and this A will multiplied with this C and I get AC, and the operation of addition will remain as it is. Similarly here, when I multiplied with this C with A, I get AC, this C with B, I get BC, and the operation of addition remain as it is. Again you can verify this property and you get the equality on both sides, which verify that the property of distributivity holds in case of matrix multiplication. Moving ahead to the next property, the existence of multiplicative identity. As I have explained you, in the case of existence of additive identity, same concept will be here. What matrix should I multiply? Now note my word, I am saying what matrix should I multiply. There I was saying that what matrix should I add to my given matrix so that I get the same matrix. Here the definition will change a little bit, that what matrix should I multiply with a given matrix so that I get the same as it is matrix. If you examine the identity in case of multiplication, it will come out to be 1 0 0 1. What is this? This is nothing but the identity matrix in case of multiplication. If you multiply any matrix, let me give you example. Okay, let's say A is my this matrix. If I multiply this A, okay, let me create some space. Okay, if I multiplied this A matrix with this matrix, what I will get? If you multiply with the same procedure, you will get here 0, here -1, 0 and 2. This is nothing but this A matrix, right? Let's take another example. Let's consider this B now. If I multiply 3 5 0 0 with 1 0 0 1, what I will get? I will get here 3, here 5 times 0 0. Okay, I multiply 3 into 0 0, 5 1 5. Okay, 0 1, 0 into 1 0, 0 0 0, and here also I get 0. Okay, again you can see here this multiplication matrix and this matrix are same. That means this particular matrix, which matrix is acting as the identity matrix. Why I am saying identity? Because whichever matrix you multiply with this particular matrix, you get the same matrix as the result. So this is the identity matrix in our case. Now don't get confused that this is the only identity matrix. This is the identity matrix in case my given matrix is of 2 by 2 order. Okay, matrix multiplication is possible when the order is compatible, right? I have told you how we check that whether the matrix multiplication is possible or not. I have told you, you can verify that whether the multiplication is possible or not. After due checking, then you can proceed for the multiplication. In case the given matrix is of 3 by 3 order, then our identity matrix will change correspondingly. In that case, this will be my identity matrix. This is of the order 3 by 3, right? This is how our identity matrix will change according to the matrix given to us. Okay, let's quickly discuss this example number 16. What it is saying? It is saying we are given with A matrix, B matrix, C matrix, and we have to find this, okay, and we have to finally show that this is equals to this. What is this basically? This example 16 is nothing but the application of this property of associativity. Here in this example we have, using the matrices, we have shown that the property of associativity is well established, right? So as I have given you the example of associativity with these matrices, you can yourself verify that yes, the associativity property clearly holds. How you will proceed? Let me give you hint. First you will multiply BC. First multiply these two matrices, okay, then whatever the resultant you get, then multiply with that resultant with A matrix. Okay, you are done with this part. Then after this, to find this part, you first multiply AB, then the resultant will be multiplied with C, you get this part. And after getting both the part, you will see that they will be 100% equal. Why? Because the associativity holds in case of matrix multiplication, right? Before doing anything, before going ahead, first check that whether the multiplication is possible or not. This is something I am repeating again and again because these are very tricky points where the examiner can make you confused in your CUET exam. Maybe he can give 4 options and ask you that what will be the resultant multiplication. In some case the multiplication is not even defined, so your time will get wasted there. First of all, check whether the multiplication is possible or not. If it is not possible, then how can some resultant can come out of it, right? So you need not to confuse there. First of all, check the compatibility, check whether the multiplication is possible or not. After checking, you can go ahead with the multiplication. Okay, let's move ahead to example number 17. Okay, in this example again we are given A matrix, B matrix, C matrix. We have to calculate AC matrix, BC matrix and this matrix. All these we have to calculate individually. Then we have to verify that this is equals to this. What is this verification? This is the verification of distributive property. As this is the distributive property I have shown you, right? This is the verification. This example is the verification of this distributive property. Again, it will definitely hold. Why it will hold? Because we know the multiplication of matrices follows the distributive law, so it will definitely hold. Here it is shown that addition of AB will come out to be this. When I multiply this with C, I get this matrix, right? Now I am separately finding AC and BC and checking whether this is equals to my this matrix or not. I will find that yes, both they are equal. Clearly they are equal. This what does this suggest? This suggests that the property of distributive holds. Now one more question can be asked from this is that which property is holding here. The examiner can ask you that if it is holding, then what can you say about the property of multiplication of matrices? In that question you will report that this particular expression suggesting that the distributive law holds in case of matrix multiplication. I hope it is clear to you. Okay, all these multiplication I will suggest you to do by yourself. When you will do all these multiplication and addition by yourself, then you will become very handy with all these multiplication and all these calculations. They are just simply calculations, nothing else. Just be focused while doing calculation, be patient, and you will get through it. Similarly, this question might seems to be some hard question or quite a dangerous question, but it is not so. Just calculations, that's it, nothing else. First let's break it one by one. Here we have to find a cube. Now how we will find a cube? A cube is basically multiplication of a 3 times. How we can do this? first multiply a with multiply a with itself, that is 2 times, then we get a square, again multiply it with a, we get a cube, right? In this way we get what we get a cube. Okay, now we will find minus 23a. What is this? This is the multiplication of a matrix by a scalar. I have explained you how we will multiply a matrix with a scalar. In case of multiplication of a matrix by a scalar, we multiply each and every entry of the matrix with that scalar. What is the scalar here? It is minus 23. You can easily multiply. Now next, let's see this part. Here minus 40 is the scalar which is multiplied with this I. What is this I? This I is the identity. Now which identity you will use here? You will use this identity, or you will use this 3 by 3 identity. Give me the answer. We will here use the 3 by 3 identity. Why? Because the matrix here given to me is of 3 by 3 order. So the addition or subtraction will only be possible when we have the matrices of the same order. This is I have discussed with you where in the video where I discussed the matrix addition. Okay, so the identity which we will use here is this 3 by 3 identity. Hope it is also clear to you. Here we have find first a square, we get this matrix, then this a square is multiplied with a, we get this matrix. Now we will separately find this and this and do the necessary calculation. Finally we get this, right? This is just simple calculation, nothing else. Okay, now move to this example number 19. What does this example number 19 saying? It is saying that in a legislative assembly elections, a political party hired a public relations firm to promote its candidate in 3 ways: via telephone, house calls and letter. The cost per contact in paisa. This is important. This is something which is important. We need to take care about it. Okay, is given in matrix A. This is basically the cost. Cost in which denomination? A cost in paisa. Okay, maybe I need to decrease the size. Okay, so these are all paisa. Remember this thing. Also, the number of contact each type made in the cities X and Y is this. We have to find the total amount spent by the group in the 2 cities. Which are the 2 cities? X and Y. Now how I will calculate it? Okay, what I have given that the cost making, what is the cost of making a telephonic conversation, what is the cost of making telephone is 40 paisa, and in the X city I have made 1000 calls. Then what is the total cost of making telephone? It is obviously 1000 into 40, which is nothing but what I will get? I will get 40,000, right? And since it is paisa, so I will divide it by 100. What I get? I get rupees 400. Now this is very general question. We have asked the total amount spent. What we are given? We are given the cost of making per call, or cost of making per house call, or cost of sending a letter. We are giving individual costs, and we have given the total of house call, telephonic calls or letters sent. What we have to do? We have to simply multiply. Now one things come here. What we will multiply? We will multiply A matrix with B or B matrix with A. This is the important question. How we will check? See, at the end we have to find the total amount. That means we have to make multiplication. That is, multiplication is final. That is, we have to see which way it is compatible. If I multiply A with V, let's see whether this multiplication is compatible or not. See, the order of A is 3 by 1, right? 1, 2, 3, 3 rows, 1 column. Hope it is clear. 3 by 1. And the order of B is 2 by 3, right? 2 rows, 1, 2, 3 columns. 2 rows 3 column. Now see whether the number of columns is same as number of rows. No, they are not same. That is AB, the multiplication of AB is not possible. Let me check whether BA is possible. So the order of B is 2 by 3 and the order of A is 3 by 1. The number of rows, the number of columns of B is same as number of rows in A. That means this matrix multiplication is possible. So we will find BA, not AB. This is important. I hope it is clear to you why we are finding this. So BA is find it. How we have find it? We have find it by simply multiplication. So this is the total cost. Don't forget to divide each and every cost you have received by 1000. Why? Because this is in paisa and we have to convert it in we have to convert it in rupees. So divide it by 100. Sorry, I have earlier told you divided by 1000. It will not be divided by 1000. It will be divided by 100 because 100 paisa is equals to 1 rupees, right? So we will divide it by 100, as simple as that. So that's it for today. We will discuss the exercise in the next lecture. Till then, keep studying, and in case you have any doubt, please write it in the comment section. You can also connect with us via various social media handles. Thank you.